Today we'll be going over the notes on Target 9, solving a rational equation. In order to add or subtract fractions, and therefore rational expressions, we have to have a common denominator. So remember, whenever you add and subtract fractions, you've always had to find the common denominator between them. That is also going to hold true as we solve our rational expressions. The other thing we have to worry about is finding extraneous solutions. If you remember when we graphed, we had those vertical asymptotes because they made our denominator equal to 0. So whenever you solve, you need to go back and check your answer by making sure that your answers won't make your denominator equal to 0. Okay, let's look at problem 1. Problem 1 is going to be by far the easiest problem we have the entire time because when I look at this, all my denominators are x minus 8. If your denominators are all x minus 8, you don't have to worry about them, and we're not actually going to even use them in the problem. You can think this a little easier if I told you 3/2 equaled x over 2. We know x would have to be 3 to make these two fractions match. In order to get 3, you didn't have to worry about 2 because it was the same already. We're going to use that same logic up on number 1. Since my denominators are all the same, I'm not going to worry about my denominators at all. So I'm going to rewrite this problem as negative 4x minus 11 equals 25. Now it's a linear equation like you've been solving for years. So I'm going to add 11 over, negative 4x equals 36, and I'm going to divide both sides by negative 4. So x equals a negative 9. Check, make sure if I plugged negative 9 in for x in my denominators, I'd have negative 9 minus 8, which is negative 17. That's not 0, so x equals 9. Negative 9 is not an extraneous solution. Okay, now 2 is going to get a little bit harder. When I look at 2, I don't have a common denominator anywhere. So the first step you want to do here is you want to factor all of your denominators. Now sometimes you're going to have some that you can't factor. That's okay, factor what you can. So starting with 4, I can't factor 4 any further, so I'm going to leave it as 4. 4x minus 24, I can pull out my greatest common factor of 4, and I'm left with 4x minus 6. On the right-hand side, I just have x minus 6. There's nothing I can factor from there. After you factor, the second thing you need to do is you need to find your least common denominator. Okay. To find my least common denominator, I need to make sure they have each part of my factors, but I don't want to add any extra. So looking at this, my first denominator here, I have 4, but I'm missing this x minus 6 part. So I'm going to multiply this first fraction by x minus 6. We'll multiply both the top and the bottom, so really we're just multiplying by 1. Now my denominator here is 4x minus 6, which makes it match my second denominator. So those two have a common denominator, but I want everything to have a common denominator. My third fraction has x minus 6, but it's missing the 4, so I'm going to multiply the top and the bottom here by 4. When you do this, there's a couple things we need to remember. Up top here, I have 3 times x minus 6. I have to distribute 3 in. So I'm going to have 3x minus 18. Now, whereas I'm always going to distribute in the numerator, I'm never going to distribute in the denominator because I'm just looking to make sure I have the same thing in each one. So I have x minus 6 times 4. This second fraction, I didn't have to change anything. It already had everything we needed to make that common denominator. So I have 2x over 4. I'm going to put it in the factored form just so I can make sure that I have everything the same. On the right-hand side of the equation then, I had to multiply by 4. So I'm going to multiply the top by 4. I get 32. Again, the denominator, I would never multiply that out. I have x minus 6 times 4. So I have a common denominator here because on every denominator I have that factor of x minus 6 and I have that factor of 4. Now the problem becomes like number 1. I don't need to worry about my denominators anymore, so I'm just going to rewrite it, losing every denominator that I had. So I have 3x minus 18 minus 2x equals 32. Combine your like terms, so 3x minus 2x leaves me with x minus 18 equals 32. And we'll add 18 to both sides, so x equals 50. Go back and check. Make sure if you plug 50 into any of your 3 denominators that it doesn't equal 0. On these, none of them will be 0, so x equals 50 is our solution. Okay, let's look at number 3. So number 3, again, I have 3 fractions and none of them have that common denominator. For me, I would think of this as my variables, and I would also think of this as my numbers. So when I start with numbers, I have 6, 12, and 4. So I want the least common denominator between 6, 12, and 4, so I'm looking for that least common multiple, which is going to be 12. So to get 12, I'm going to have to multiply this first fraction by 2 on the top and the bottom, and I'm going to have to multiply the last fraction by 2 on the top, 3 on the top and bottom. I'm multiplying by 2 because 2 times 6 is 12. I'm multiplying 3 because 4 times 3 is 12. So now all my denominators have 12, but all my denominators also need to have x so they can be the exact same. So I'm going to have to multiply this second fraction by x. So now when I simplify, my first fraction I'm multiplying by 2. 2 times 3 is 6. 2 times 6x is 12x, so I have 6 over 12x. For my second fraction, I have minus 9 times x is 9x. 12 times x is 12x. For the third fraction, 11 times 3 is 33. 4x times 3 is 12x. I have my common denominator, so I'm going to rewrite it without the denominator. So 6 minus 9x equals 33. Subtract 6 from both sides. Negative 9x equals 27. And divide both sides by negative 9. So x equals negative 3. When I plug negative 3 in, I wouldn't get 0 in any of my denominators. So x equals 3 will be my final solution. Okay, number 4, we have to again start with factoring. So looking at this first fraction's denominator, I notice that I have a greatest common factor of 5. So I'm going to pull 5 out, and I'm left with x plus 2. I can't factor 5, and I can't factor x plus 2, so I can't factor either of my other denominators. So now I need to see how I can make them common. Well, this first one has 5 and x plus 2. My second fraction only has 5, so I'm going to have to multiply the numerator and the denominator of my second fraction by the x plus 2. My third fraction has the x plus 2, but it's missing the 5, so I'm going to multiply that third fraction by 5. So rewriting this, my first fraction I didn't have to do anything. I have 18 over 5 x plus 2. My second fraction I had to multiply by x plus 2, so I'll distribute in my numerator. So I have plus 4x plus 8. My denominator, I'm just going to leave as 5 times x plus 2. My third fraction then I had to multiply by negative 5, so I have negative 30 over 5 times x plus 2. Our denominators are the same everywhere, so I'm going to rewrite this as 18 plus 4x plus 8 equals negative 30. Combining my like terms, I have 26 plus 4x equals a negative 30. Subtract 26 over, and 4x equals a negative 56. So last but not least, we're going to divide both sides by 4 to get x by itself. So x equals negative 14. Check and make sure it doesn't make any of my denominators equal to 0. So I'm done with x equals negative 14. Okay, on the back side, we're going to continue to do the same process. We're just going to have some bigger denominators that we need to factor. So this first one here, I have 3 terms. I'm going to use my AC method, but I do notice my A value is 1, so we can use the shortcut. So looking for 2 numbers that multiply to 6 and that add to 5, I have a positive 3 and a positive 2. Since my A value is 1, I can use my shortcut method, and that's going to factor to x plus 3, x plus 2. My other 2 denominators I can't factor, but I notice that both of them are missing something. The first one has x plus 3, but it's missing x plus 2. So I'm going to multiply the top and the bottom by x plus 2. My last fraction is missing the x plus 3, but has the x plus 2. So I'm going to multiply the last one by x plus 3 and x plus 3. The first one I don't need to multiply by anything because it had both of those factors in it. So now I'm left with 12 over x plus 3, x plus 2, plus distribute the 7, 7x plus 14 over x plus 3, x plus 2, and that equals, distribute your 2, 2x plus 6 over x plus 3, x plus 2. My denominators are all the same, so I don't need to worry about them anymore. Rather than rewriting it, I'm just going to cross those out. So up top, I have 12 plus 7x plus 14 equals 2x plus 6. I'm going to combine my like terms. So I'm going to do 12 plus 14. So I have 7x plus 26 equals 2x plus 6. Subtracting 2x from both sides, I get 5x plus 26 equals 6, and I'll subtract 26 from both sides. So 5x equals a negative 20, and dividing by 5, x equals negative 4. Make sure negative 4 doesn't make your denominators equal to 0. It works in my first one, it works in my second one, and it works in my third one. So x equals negative 4 again is not an extraneous solution. Okay, number 6 is another one. We don't have that addition and subtraction, so I'm not going to factor. I'm just going to go straight to trying to make them look alike. So in my denominator, looking at my numbers, I have 10, 5, and 2. Between 10, 5, and 2, my least common denominator for those would be 10. So I'm going to multiply everything, so that it looks like 10. So I'm going to start with 5. To make 5 look like 10, I'd have to multiply by 2. So I'm going to multiply my second fraction by 2. My third fraction, I have 2x, so I'm going to have to multiply that by 5 to get 2 to look like 10. My first fraction is missing something though. It is missing x. So I'm going to multiply both the top and the bottom by x. So right now I have x over 10x plus 8x over 10x. That equals a negative 45 over 10x. Now my denominators are all the same, so I don't need to worry about them. I have x plus 8x equals a negative 45. So 9x equals a negative 45. And dividing by 9, x equals negative 5. Again, when I plug those into my denominator, I'm not going to get 0, so it's not an extraneous solution. Okay, number 7. Number 7 is nice and easy again. I'm noticing that my 3 denominators are already the same. So I'm going to go ahead and just write down my numerators. So 14 plus 7x equals 63. Subtract 14 from both sides, and I have 7x equals 49. Divide by 7, and x equals 7. Checking my denominators, none of them are going to be equal to 0, so we don't have any problems there. Last but not least, it looks like we're going to have to do some more factoring. I can't factor x minus 6, and I cannot factor x plus 2, but I can use my AC to factor x squared minus 4x minus 12. I need two numbers that multiply to negative 12 and add to a negative 4. So it's going to be negative 6 and positive 2. My a value is 1, so I can use my shortcut. So I have x minus 6 and x plus 2. My first fraction has the factor of x minus 6, but it's missing x plus 2, so I'll multiply the top and the bottom by x plus 2. My second fraction has the x plus 2, but it's missing the x minus 6. So for the first fraction, I'm going to distribute 2 to everything up top. So I have 2x plus 4 over x plus 2, x minus 6. In my second fraction, I'm going to distribute 7 to everything. So I'll have plus 7x minus 42 over x plus 2, x minus 6. For the third fraction, we don't have to change anything, so we're going to have 4x plus 2 over x minus 6, x plus 2. My denominators are all the same, so I can take my numerators and just set them equal to one another. So 2x plus 4 plus 7x minus 42 equals 4x plus 2. Combining my like terms on the left-hand side, I'm going to get 9x minus 38 equals 4x plus 2. Subtracting 4x from both sides, I have 5x minus 38 equals 2. I'll add 38, so 5x equals 40, and I'll divide by 5, so x equals 8. Again, please always go back and check, make sure it doesn't make your denominator equal 0. It doesn't, so that will be our solution. Please come in if you have any questions.